So hey guys, myself Animesh Bhattacharya, and I'm from Nagpur, Maharashtra, and I have done MSc Chemistry, and I have a teaching experience of 2 years, and today we are going to discuss about solid state chemistry. So there are different forms of matter, and solid state is one of those forms of matter. There are different states of matter like solid, liquid, gases. Today we are studying solid state, and there are different points that we need to cover in solid state. First we will start with some of the basics, and then we will be studying about the crystal lattice, or also known as it is also known as space lattice. Third point is about unit cell. Fourth point is about lattice point. Fifth will be the classification of this unit cell. So this is how we are going to go through this session. First we are going to see the basics of the solid state. So as I told you, solid state is one of the states of matter, and it is the state in which the particles are highly ordered, they are arranged very specifically, and they have a lot of, the congestion is there is a lot of congestion. The particles are having, there are like too many particles in a small space. So this is how the solid state is there. Particles are like densely present. Liquid state, the particles are slightly, they have gap in between them, and in gaseous state the particles have a lot of gap in between them. So this is how we can classify solid, liquid and gaseous state on basis of the arrangement of particles. Also we can classify them on the basis of thermal energies. So gases are going to have the highest thermal energies. Reason is the particles can move. They have space in between them, so they can move, and they can have a lot of thermal energies as compared to solid state in which the particles are densely packed, so they don't have any space to move, so their thermal energy is going to be less as compared to that of gaseous state. Gaseous state is the highest thermal energy, then comes the liquid state, then comes the solid state. So this is going to be the order in which the energies are distributed. Then comes our first important point, that what is crystal lattice. So for that I have to show you this Rubik's cube. This is a Rubik's cube, and so this is a cube. It is having a geometry. It is occupying a space in 3D lattice. That is what our crystal lattice or space lattice is all about. It is having different cubes in it. There are small cubes in it. Those small cubes are combining, and it is giving us a bigger cube, and which is known as space lattice, which we are referring as space lattice. The small cubes which are joining together, they are known as unit cells. And if I take out one of these cube from this bigger cube, if I take out one of these cube, this is one of those cubes. And these cubes is having these points which are combining in specific geometry. So this is known as a lattice point. These points are lattice points. They are combining together to give us unit cell. So that is the definition of lattice point. Lattice points are the points that combine to give us unit cell. This is the unit cell. They are combining to give us one small cube, and these small cubes are combining in all arrangements. They are combining in all entire arrangement, and they are giving us a crystal lattice or space lattice. It is also known as space lattice. So unit cells combine in 3D arrangement entire fashion, and they are giving us crystal lattice. So this is about lattice points, unit cell and crystal lattice. Now I'm going to specifically mention about unit cell because we're going to study this in detail. There is a classification of this unit cell, and there are two classification. First classification is on the basis of the lattice points which are present. These are the lattice points. According to these lattice points, the geometry of these lattice points, we can classify them into primitive. So this is the first classification, and the second classification, I am talking about this first classification in which we are discussing about the lattice points. This is according to the lattice points, and this can be divided into further two types: primitive and non-primitive. Primitive unit cell and non-primitive unit cell. In primitive unit cells, the lattice points are present only in corners. This is a unit cell, and in primitive unit cell, the lattice points are present only in corners, and there are 8 corners totally. So there are, in this primitive unit cell, there are 8 corners, and there are 6 faces. 1, 2, 3, 4, 5, 6 faces. Edges are going to be 12 if you count these edges. This is one of these edges. This is second edge. So if you count them, they're going to be 12. Faces are 6. This is top face, bottom face, left face, right face, front face, back face. These are 6 faces. Edges are there, which are 12 in number. Then there are diagonals. If you are considering this face, top face, these two are diagonals. If you are considering the right face, these are the 2 diagonals. In entire face, in all the faces there are 2 diagonals per face. Total 6 faces are there. So 6 into 2, 12 diagonals are there entirely in primitive unit cell. And if I talk about the diagonals which are present, this is one diagonal, this is the second diagonal, this is the third diagonal, and this is the fourth diagonal. From this end to this end, this is a first diagonal. It should pass through the center, and the molecule should rotate like this. A line should pass through the center, and it should come to the opposite end to end. The middle part, it should pass through the body center. This is the body center, or the point which is exactly present at the center of the cube. This is first body diagonal. Similarly, you can take this from this end to this end to this end, second body diagonal. Third one from this end, first we took from here, second we took from here. We can take from this end to this end, third one, and from this end to the opposite end, the fourth end. So there are 4 body diagonals in the primitive unit cell. Now we are going to discuss about the non-primitive unit cells. They are of body-centered unit cell. So in primitive unit cell, the lattice points are only present at the corners, but in non-primitive one, it is also present at the body center, or it can be present at the face centers, or it can be present at the 2 opposite faces. This is known as end-centered. Lattice points are already present on the corners in all these, but apart from the corners, they are also present at the face centers, or like in opposite faces, or in between the edges. This is known as edge-centered. So non-primitive can be classified into body-centered, face-centered, FCC, end-centered, END, end-centered. This is edge-centered, EDGE, edge-centered. So these are the 4 types of non-primitive unit cells. So this was the first classification. This was the first classification of the unit cells according to the lattice points. Now we will be classifying these unit cells in the second type of classification, in which we will be using the angles in between the sides of unit cells. The angles are there. This is first, consider this as alpha angle, this is beta angle, this is gamma angle. We took x-axis, we took y-axis, we took z-axis. You can take this also as x-axis, this also as y-axis. That is not mattering here. There are 3 axes, and in between 2 axes we are considering this as alpha, beta, gamma. These are sides. This is A side, this is B side, this is C side. So according to all this, we are classifying this into a second category. We are classifying unit cells into a second category known as classification according to sides, angles, and according to this we are having a specific term known as 7 crystal system. So you might have heard about 7 crystal system. So 7 crystal system is very important from the exam point of view. So if I tell you about the 7 crystal system, there is a mnemonic according to which you can remember the 7 crystal systems. I am writing it here. Cute are mother. So according to this mnemonic, you can easily remember the 7 crystal systems. Cu means cubic, Te means tetragonal, Our means orthorhombic, Mo means monoclinic, T means tetragonal, He means hexagonal, R means rhombohedral. So these are the 7 crystal systems. I'm going to write the entire crystal systems on this board, and I'm going to show you a trick that how you can remember all the crystal systems very easily. You don't need to mug up things, and you just need to remember the 2 of those points which I'm going to tell you. And now I'm going to rub this and write all the crystal systems, and I'm going to tell you how can you remember those all. So guys, I have written all the crystal systems, their axial lengths, their interfacial bond angles. Now we need to know how can we learn this. So these are the axial lengths. For this you need to remember these unequal sides data: 0, 1, 2, 2, 2, 1, 0. There is a pattern 0, 1, 2, 2, 2, 1, 0. If you remember this number, you can write this very easily. There are 0 unequal sides, everything is similar. A is equal to B is equal to C. There are 0 unequal axial lengths. There is 1 unequal axial length. A is equal to B, B is not equal to C. Then there are 2 unequal sides. A is not equal to B, A is not equal to B, B is not equal to C. There are 2 crosses, 1, 2. We are going to cross these 2. Similar for these 2 also. Then you have again 1. You have to do 1 cross, and 0 crosses, everything is similar. So there is a pattern 0, 1, 2, 2, 2, 1, 0. This is how you can easily remember about the crystal systems which are present, about the axial lengths. Now talking about interfacial bond angles. In this, first 3 cases are very easy. Alpha is equal to beta is equal to gamma is equal to 90 degree. So these 3 cases are very easy to remember. You don't need to do anything. You just can write alpha is equal to beta is equal to gamma is equal to 90 degree. Remember we are talking about these angles: x axis, y axis, z axis. We are talking about these interfacial angles. This is angle between the back phase and this phase which is present over this side. So this is one phase. This is between z and x, that is between the back phase and the extreme left phase, and this is between the z1 and x1. So there are 3 alpha, beta and gamma angles. So we are discussing those angles, and these were the sides that we discussed: A, B and C. These were the sides. So these are the angles, these are the sides, and you can easily remember these 3: alpha is equal to beta is equal to gamma is equal to 90 degree. But talking about this, you need to remember this, you need to learn this. This is easy. Alpha is not equal to beta, is not equal to gamma, is not equal to 90 degree. Everything is dissimilar. There is nothing similarity. You need to cross everything, and this, you can easily remember this. So this can be easily remembered, but you need to learn this one and you need to learn this one, because this is something that you need to remember. That is for hexagonal, and for monoclinic you need to learn. This data is also very easy. You can easily remember this data. So this was about the interfacial angle. This was about the axial lengths. And how can you remember the 7 crystal systems? This is the mnemonic: cute are mother, cubic, tetragonal, orthorhombic, monoclinic, triclinic, hexagonal, rhombohedral. So through this you can easily remember these 7 crystal systems. There are some examples of these 7 crystal systems. For every column there is an example, so we are going to discuss that in our next class. So guys, this was about the solid state. These were the basics of solid state. 7 crystal system is quite important for examination point of view. The examples are generally asked. The axial lengths and interfacial bond angles are frequently asked in exams. So I hope you will study this, and I will see you in the next class. Thank you.